In this section, we provide a brief overview about the Internet of Things communication protocols and technologies. As the Internet of Things is growing very rapidly, there are a large number of heterogeneous devices connecting to the Internet. To enable the communication between heterogeneous IoT devices, proper protocols are required. There is a plethora of communication protocols in IoT, and the selection of the appropriate protocol is based on the characteristics and requirements of the network. For example, the communication range, the data rate requirements, and the number of IoT devices affect the selection of the communication protocol. Some of the major IoT technology and protocol are shown in the list. LoRaWAN is the most adopted type of LPWAN, low power wide area network, and promises ubiquitous connectivity in outdoor IoT applications. LoRaWAN network architecture is deployed in a star of stars topology. LoRaWAN targets wide area network applications and is designed to be a low power protocol. Specifically meets requirements for low power consumption and supports large networks with millions and millions of devices. Data rates range from 0.3 kbps to 50 kbps. In the upcoming sessions, we will investigate more low-power wide-area network protocols, Sigfox, narrowband IoT, and LTE-M. The first communication protocol to present is Bluetooth. Bluetooth is an open standard protocol and fairly popular, but is limited in range, up to a few meters. Therefore, its application is limited to small personal area networks. The Wi-Fi Alliance has recently developed Wi-Fi Halo, which is based on the IEEE 802.11a standard. It consumes lower power than a traditional Wi-Fi device and also has a longer range. This is why this protocol is suitable for Internet of Things applications. The range of Wi-Fi Halo is nearly twice that of traditional Wi-Fi. Because of the relatively lower frequency, the range is longer since higher frequency waves suffer from higher attenuation. Zigbee. It is based on the IEEE 802.15.4 communication protocol standard and is used for personal area networks or PANs. The IEEE 802.15.4 standard has low power MAC. Zigbee was developed by the Zigbee Alliance, which works for reliable, low energy, and cheap communication solutions. The range of Zigbee device communication is very small, 10 to 100 meters. It is basically designed for low power consumption, allowing batteries to essentially last forever. Zigbee makes possible completely networked homes where all devices are able to communicate and be controlled by a single unit. The 6LoWPAN, IPv6 over Low Power Wireless Personal Area Networks, protocol, is a very popular standard for wireless communication. Its main characteristics is that it enables communication using IPv6 over the IEEE 802.15.4 protocol. 6LoWPAN devices can communicate with all other IP-based devices on the Internet through an adaptation layer between the 802.15.4 link layer and the transport layer. Another communication protocol that it is mainly used for home automation is Z-Wave. Is an RF-based communications technology designed specifically for control, monitoring, and status reading applications in residential and light commercial environments. It is a very efficient, low-energy technology which runs on a mesh network, meaning there's no single point of failure. Narrowband IoT is an initiative by the Third Generation Partnership Project, 3GPP, the organization behind the standardization of cellular systems. Narrowband IoT works in one of three ways: independently, in unused 200 kHz bands that have previously been used for GSM, and finally on LTE base stations allocating a resource block to NB-IoT operations or in their guard bands. Narrowband IoT supports low data transfer rate up to 62.5 kbps. LTE-M is a less complicated version of the well-known and broadly used 4G standard. LTE-M supports downlink and uplink speeds up to 1 Mbps with a latency of 50 to 100 milliseconds. It is more flexible and suitable for real-time communication.